that has already asked in GATE 2021 physics paper. So these questions are really important and conceptual, and these questions are like, it can be like coming in the upcoming exams like NET, GATE, JEST. So please watch this video and understand that how to solve and handle this kind of questions. So the first question that come in the GATE 2021 exam, which we'll discuss, that among the term symbols 4s1, 2d7 by 2, 3s1, and 2d5 by 2. Choose the option or options possible in the LS coupling notation. The first option is 4s1, is it possible or not? Second one is 2d7 by 2. Third one is 3s1, and fourth one is 2d5 by 2. So among these term symbols, which is the possible option and which is not possible? So first of all, you have to know what is term symbol. So you know, in atomic and molecular spectroscopy, we denote a state, electronic state of the molecule with respect to the term signal symbols with the molecule or with atoms. So what does it mean? This 4s1 means that you are writing that this is 4 is the 2s plus 1, that is multiplicity, s is the L value, and 1 is the J value, right? So 4s1, so in general we write it like this is the L's, and this is the I have to, like, I need to write it. So let us just write it 2s plus 1, and this is J. So this is the term symbol. So what is LS coupling? So whenever you are considering multi-electronic system, the atoms consist of multiple electrons. The most easiest atom is like one electronic system atom is hydrogen. But if you go to helium atom, if you go to carbon, like apart from hydrogen, if you consider any other atom, they have multiple electrons. So multiple electrons will have multiple orbital angular momentum, different spin angular momentum, right? So when you are considering all these electrons confined inside atomic system, you have to consider how these momentums are interacting with each other. So whenever for the multi-electronic atoms we are considering, then the spin orbit coupling, that individual spin and individual linear angular momentum coupling is weak. But what we can assume, we can presume that the orbital angular momenta of the individual electrons, they will add with each other and they will form a resultant orbital angular momentum L, that is capital L. So, and likewise, similarly, we can think that individual spin angular momentum is S1, S2, S3, suppose, they will also couple with each other and they make a resultant spin angular momentum capital S. Now this resultant orbital angular momentum and the spin angular momentum, they will form the total angular momentum, that is J, that is L plus 1. So first you need to understand that why we have to consider this LS coupling notation for a atom having multiple electrons. It is because the electrons they have their individual spin and orbital angular momentum. They will interact with each other. The system will be the total resultant of the individual momenta of orbital momenta and spin angular momentum. And further you have to combine to form the total angular momentum. Okay. So this is J value. So this scheme is the LS coupling scheme. Now let us first see that whether these four options, which option is, or which two options or three options are possible combination of this term symbol. So the first one is 4s1. So the multiplicity M is 4, that is 2s plus 1 equals to 4. So S value is 3 by 2. And since this is S state, so L equals to 0 is the S state, right? Now what will be J? J equals to L plus S. So that is 0 plus 3 by 2. So it will become 3 by 2. So here the term symbol should be 4s 3 by 2, but here it is written as 4s1. So 4s1 is not possible. So option A is incorrect. The second term symbol is 3d7 by 2. Now what is the multiplicity? Multiplicity m equals to 2s plus 1, which is 3. So you can find out the value of s, that is 1. And the value of L is 2 because it is SPD 012. Since it is a D state, so L equals to 2. Now what will be the possible J L plus mod of L plus S value? That is, it can be plus L plus S2 mod of L minus S. So L plus S means that 2 plus 1, that is 3, and L minus S equals to 2 minus 1 is 1. So 1, 2, 3, these are the three different values. So now you see that J value is 1, 2, 3 should be there, but there is no value of J that has 1, 2, 3. It is 7 by 2. So D 3D7 by 2 is also not possible. So option B is also incorrect. Let's look similarly for the option C, that is 3s1. So here S is 2s plus 1 value, multiplicity is 3. So S value is 1. Since it is S state, so L equals to 0. And for L equals to 0 and S equals to 1, J is equal to 1. So the value 3s1 is possible. So option C is correct. And the last option is 2d5 by 2. That is, here S is half. Since it is a D state, so L equals to 2. And J will have 2 plus half up to 2 minus half. So 2 plus half is 5 by 2. 2 minus half is 3 by 2. So here also this 2d5 by 2 is also possible. So these two options C and D, these are the possible options. Now let's come to the next question. The next question is also very conceptual question, and it is very easy question, and this kind of questions is asked many times in GATE, JEST, NET exam. So the question is, to sustain lasing action in a 3-level laser as shown in this figure. So this is 0, 1, 2. So three different energy levels for this lasing action has been considered. So this is a 3-level laser system. And what is the necessary condition for this lasing action to be happened? First one, the conditions are here. Lifetime of the energy level 1 should be greater than the energy level 2. The next option is population of the particles in level 1 should be greater than that of level 0. Third option is lifetime of the energy level 2 should be greater than that of the energy level 0. And the fourth option is population of the particles in level 2 should be greater than that of the level 1. So which is the correct option? First, you have to understand that what is the principle for a 3-level laser system. For a 3-level system, there is a first level, that a ground state, then an excited state, upper excited state, and then from that you have to consider another second highest excited state. So the ground state, you will excite the atoms to the highest state, the second excited state, to get a population like a pumping action. And then this, from the, suppose this is 0, this is 1, and this is 2. So from this 2 level, it will come to one state, and then from 1 it will come to 0, and in this energy range you will get the laser action. So what you want here, that most of the atom should stay here for maximum time, so that you will get a high condition of highly population inversion for this laser action, right? So I sorry for this poor drawing. So these are suppose atoms. So you need maximum atoms to be populated here, so that you will get a huge laser action from this state to this state. So what do you need here? You need the first condition, that the lifetime of the energy level 1 should be greater than energy level 2. Because if the energy level 2 has greater lifetime, then most of the molecules atom should be here, not here, but you don't need it. So the lifetime here you need it to be more, so that the laser action would be like highly populated upper layer level, in excited level, it will come back and you will get a huge laser action, right? So first condition is true, that is the lifetime of the energy level should be greater than energy level 2. And the second condition, that is the population of the particles in level 1, that should be greater than level 0. So A and B, that are the most necessary condition for a 3-level laser system. Here I have also included a 4-level laser system, so that you can ask and find out that what are the conditions for the important or necessary condition for a 4-level laser system to happen lasing action. So you just find out the answer and tell me what are the necessary conditions for 4-level laser. Okay, so in the next question, this is also very important question, and this kind of question is asked several times and it is very easy to solve. The question is, a light source having its peak intensity at the wavelength 289.8 nanometer, which is calibrated at 10,000 Kelvin, which is the temperature of an equivalent black body radiation. Now, considering the same calibration, the temperature of light source in Kelvin having its intensity peak at wavelength 576.9 579.6 nanometer is how much? So, what is given here? It is given that intensity peak at wavelength 298, and that intensity peak of wavelength lambda maximum for 289 nanometer. For this you will get the temperature for 10,000 Kelvin, and then you have to find out what is the temperature for another lambda max, which is 579.6. So what will be the temperature of the light source? So you know how to calculate the temperature of the black body. You have to follow this Wien's condition, that is lambda m into T equals to V, that is the Wien's displacement law. So lambda max is the maximum lambda value and T is the temperature of the corresponding black body. And you have to understand why this kind of physics is important, because here suppose you are considering any kind of astronomical object. You don't really, you can't go there to measure the temperature. But what you can observe, from what you can find out, you can find out the range of wavelength. It is coming to your eyes or coming to the telescope. Through the telescope you know the wavelength of the light. So from that, coming out of the object, from that wavelength of the light, you can find out what is the temperature of the object, astronomical object. So that's why Wien's displacement law is so important for astrophysics. Okay, so let's come back to the problem, that is lambda max into T is the constant. So what we can tell, that lambda max 1 T1 should be also followed for another lambda max 2 into T2. So this put this condition into your problem, that is first, that is 5 for this 579.6 nanometer, you have to find out the temperature. Let us take the temperature as T. So 579.6 into T, it will be 289.8 into 1000. So the answer is T equals to 5000 Kelvin. So that is the answer. And this the next question. So this question is from quantum mechanics. This is also easy to solve. So the question is, three non-interacting bosonic particles of mass m each are in a one-dimensional infinite potential well of width a. The energy of the third excited state of the system is x into h cross square pi square by 2m 2m h cross square pi square by m a square. So where x is unknown, so you have to find out x. What is x? So first, it is given that there are three non-interacting bosonic particles. So since this is non-interacting, means that they will not interact with each other. So suppose we are taking bosonic particles, we know that bosons will not follow Pauli exclusion principle. So suppose the ground state is E naught, and then there is first excited state E1 and then E2 and all, right? So this way we can think the energy levels for this one dimensional finite infinite potential well. So first of all, for the ground state, all the bosons will stay with each other, like stay in the ground state. So the energy will be like pi square h cross square by twice m square, where pi n is 1. So pi square h cross square by twice m square plus pi square cross square by 2m square plus pi square h cross square by 2m square. So it will give you 3 pi square h cross square by 2m square. This is the ground state. Now the first excited state means that two of the boson will stay here and one boson will go to the upper excited state, that is first excited state. So consider two particles having the ground energy level and one particle having the first excited state. So first excited state is here n equals to 1 value and here n equals to 2. So n equals to 2 square means that will be 4. And it will become 3 pi square h cross square by m square. Now what is the second excited state? Second excited state is 1 will be in the ground state and 2 will be in the first excited state. So for 1 into the ground state is 1 particle, so 1 into pi square h cross square by 2m square, plus for the rest of the two particles, this is the highest like first excited state, so 2 into 4 pi square h cross square by 2m square, that will be 9 pi square h cross square by 2m square. And what is the third excited state? Third excited state is all of the bosons have come to this first excited state, from ground state to first excited, like both three of the particles, that is 3 into 4 pi square h cross square by 2m square. So the answer is 6 pi square h cross square by m square. So the value of x is 6 here. And another question is that consider the atomic system, and this system has sorry, the screen that yeah, I can read it, where the Einstein A coefficient for the spontaneous emission for the levels, this is the one level, that is from A Einstein coefficient A for 2 to 1 is 2 into 10 to the power 7 second inverse, and the next coefficient from 1 to 0, it is 10 to the power 8 second inverse. So if 10 to the power 14 atoms per centimeter cube are excited from level 0 to level 2 and a steady state population in level 2 is achieved, then the steady state population at level 1 will be x into 10 to the power 13 semi cube, semi to the power minus 3. So the value of x is how much? So there are three level. This is also 1, 2, 3, three-level laser system. The coefficient from 2 to 1, that is A to 1, is 2 into 10 to the power 7 second inverse. And the coefficient for 1 to 0 is 10 to the power 8 second inverse. So what is the value of x? So here also it is given that this 10 to the power 4 atoms are already from 0 to 2 level, it is excited. So let us take this second level 2 energy level has the population N2. So N2 is given as 10 to the power 14 atoms per centimeter cube. So when the laser action will occur, so the laser action will happen that this N2 by tau 2 minus N2 by N1 by tau 1 should be like A21 N2 minus A10N1. This is the like rate of change of dN1. So now in the steady state, this dN1 is 0. So N1 is 1 by A10, A21, N2. So you have to put the value of A21, A10, and N2, and you will find the answer as 2 into 10 to the power 13 semi-inverse. So this way you can find out the solution of value of x. So what you have to understand, the condition for this laser action or the rate of change of the dn1 by dt, that is the the lasing action. So that you have to consider that it depends on the energy level and lifetime of n2. It depends on the energy level, the number of population and lifetime of n1, and that is giving you the rate of dn1 by dt. Okay, so friends, you can join our test series program that is specially designed for CSIR physics exam. So please join this. It will be really beneficial for you, this kind of online test program. You can get full length test, subjective test. You can also get for both the full length and subjective test. We will conduct every week. We will ask you that the test series, about the test series, about your preparation, and also you can join our interview guidance program. You will get like a attractive discount if you joined our test series program earlier. So thank you very much, friends, for watching this video. Please like the channel, please subscribe this channel, and also share with your friends, and stay happy and prepare for net gate exam. Thank you.